The idea behind biking that we would like to look at here is that this is the leg, the femur, and the tibia. And you can cut off the quadricep because the quadricep acts in unison with the gluteus maximus, or the butt muscle, which you see right here. So we've cut up the quadricep, and we're left with the butt muscle and an ankle joint muscle here, which is your calf. And the butt muscle works to bring the femur down with respect to the body, which is held fixed to the bike, and you have a muscle on top of your leg here, which will bring it back up. And the same thing works around this joint here, or your foot. Your calf will bring your foot around this way, and your tibialis anterior will bring your foot this way. And then these four muscle groups we can look at. We can cut it down to just two pistons, which will do the work, and they will be push-pull mechanisms, one here and one here. And you see that normally when you ride, your foot will have 2 degrees of freedom, or the entire mechanism will have 2 degrees of freedom. You'll be able to move your ankle back and forth while your butt muscle moves your leg around the machine. And what we'd like to do, for a number of reasons, is cut down that degree of freedom to either 1, or you can consider it 0 if you consider the inertia of the wheel bringing the crank around by itself and being the driving force. So we see here the 4-bar linkage of the leg mechanism, and what we're going to do is constrain the entire system so that the ankle is held fixed relative to certain positions to the bike, so that you do not have to rotate your ankle as it goes around. Your ankle is rotated for you in a comfortable manner. And the reason we want to do that is by eliminating the need to fix your ankle relative to the bike. And the reason I say we have to do that is because your quadricep and your butt provide a certain force down onto around the, we'll consider this a pivot point. This would be the axis. Provide a certain force down, and if you weren't there to counteract it, it would rip all the ligaments and tendons here. So when your weight, or the force of the leg is pushing down, the force of the calf, by an action that's hard to describe, is providing a moment in the opposite direction so that the sum of moments is 0 are on the pedal. When you're pedaling 60 or 90 RPM, you have to think about that, and your mind, better bikers, their minds have gotten used to that, but you still have to think about it, and you still have to do the energy to do that. And by using this mechanism, we've eliminated the need for thinking about that, which could be a factor in fatigue situations, the coordination of muscular movement, and the actual energy used in doing that effort. So that is the idea behind our mechanism, and there's a chance in this coordination and manipulation of all these muscles. There are actually several more muscle groups in here working together to keep the leg fixed in certain positions relative to this plane and this mechanical movement here. There's a chance that we're doing actually some negative work in this process. And by doing this, we're hoping to, by simplifying the system, to just basically a push with your butt, just push down, having it go around, having this guide your foot around. We're hoping to eliminate that possibility of negative work, keeping the simple system and having it just be more efficient overall.
Of our constrained pedal bicycle. These lines right here represent the natural motion of your foot as you pedal a bicycle normally. And we got these pedal angles from an article in Bike Tech by Shinpei Okajima. These bars right here represent our 4-bar linkage. This is the crank right here. These are 2 metal bars that we have attached to the front of the bike. This point of attachment out here was determined by a computer program done last semester by Jared Adamski, in which he determined the correct 4-bar linkage to get closest to these natural pedal angles. And as you can see, the constrained pedal angles do follow the motion of the natural pedal angles quite closely.